Intersection side distance part 2. In the last lesson, we discussed about the need for providing intersection side distance, why it is necessary to provide intersection side distance. We also discussed the concept of side triangles, particularly approach side triangles and departure side triangles. We also discussed about different types of intersection control that affect required intersection side distance, particularly different intersection control as considered by AASHTO, American Association of State Highway and Transport Officials. We also discussed about the basis for estimating required side distance, intersection side distance for two particular types of intersection control, namely no control and stop control on minor road. So, we have seen that how or what should be the basis for estimating intersection side distance for these two types of intersection control. In today's lecture, after completing this lesson, the student will be able to understand the basis for estimating required intersection side distance for four types of intersection control, considered by AASHTO, like case C, case D, case E and case F. We have already discussed about case A and case B. So, today we shall take up case C, that is intersections with yield control, case D intersections with traffic signal control, case E intersections with all way stop control and case F left turns from minor roadways. What should be the required intersection in that case? Student will also be able to understand IRC recommendations, Indian Roads Congress recommendations about intersection side distance for various types of intersection control. First, about case C, that is yield control on minor road. This is a type of intersection where yield sign is used on minor road and drivers approaching yield sign are permitted to enter or cross the major road without stopping if there are no potentially conflicting vehicles on major road. That means, whenever there is yield control or sign on minor road, drivers or vehicles approaching that intersection need not stop unless and until there is any potentially conflicting vehicles on the major road. Predominantly two types of intersections are there in terms of geometry: four-leg intersection and three-leg intersection. For four-leg intersection, two separate sets of approach side triangles should be considered. Because the vehicles need not stop, we must consider, or this is the case for approach side triangles. So, it is necessary to consider two different sets of approach side triangle, one for crossing the major road and the other set for left and right turns onto the major road. So, two different types of approach side triangles should be considered. For three-leg intersection, crossing is not a feasible maneuver. So, only one set, that is left turn and right turn from minor road to major road, that should be considered. So, only approach side triangles to accommodate left and right turns should be considered. Now, there are two possible sub cases as I have mentioned right now: crossing the major road and taking left turns or right turns. First case C1, crossing from major road. Now, while we are discussing the required intersection side distance for yield controlled intersections and for crossing from major roads, we have to find out the length of leg along the major road and also the length of leg required distance along the minor road. First, let us see the length of leg along major road. This approach is similar to case A. What was case A? Case A was the case discussed in the last session, that was intersection with no control. So, whatever way we calculated intersection side distance, you can refresh your memory about those considerations, and here also for minor road approach the same basis is used, but with slightly different assumptions. Here in this case, minor road vehicles is assumed to decelerate to 60% of minor road design speed. For case A or no control, it was assumed that vehicles will decelerate to 50% of minor road design speed. So, in that case it was 50%. In this case it is not 50%, it is assumed to decelerate to 60% of minor road design speed. That means, whenever vehicles are approaching a yield controlled intersection, drivers will reduce speed approximately to 60% of minor road design speed, with a deceleration rate up to 1.5 meter per second square. This was the same deceleration rate which was assumed for case A also. Now, for minor road approach, length and travel time, this travel time we can refer to as TA, are estimated as a function of design speed. Let us again refer to case A. In case A or intersections with no control, values for distance were recommended by AASHTO for different design speed, because the assumption is vehicles decelerate to 50% or 60% of the minor road design speed. So, obviously, the required side distance is a function of the approach speed. So, in this case, both the length and the time required to cover that distance, they are given as a function of the design speed for the minor road. So, table values are given in AASHTO. Now, travel time applies to a vehicle that slows before crossing the intersection, but does not stop. This is a basic difference for between intersection with no control and stop control and intersection with yield control. Now, here for design purpose, it is assumed that vehicles, they will slow down, they will reduce their speed following certain deceleration, and they will reduce speed up to 60% of the approach speed for the minor roads, but the vehicles will not stop. So, they will reduce the speed, but they will not stop. For that scenario, for that condition, what is the required time? That is given. So, that we are referring here as TA, approach time. Now, corrections on length or time of minor road approach is required based on approach grade. This is again similar to what was done for case A. -3 to +3% grade, approach grade along the minor road, there is no need for any correction, but from -3 to -6, correction factors will vary in the range 1.0 to 1.2 depending on the grade and the actual design speed. Similarly, the correction factor will be for +3 to +6% grade. The value will vary from 0.9 to 0.1, again depending on grade and design speed. This is similar to what was used for case A to apply corrections based on grade. So, a similar correction is applied here also. Now, let us see how the length of leg along the major road can be calculated. Let us try to understand the basis for this. What is the basis for doing that? So, the basis is sufficient travel time for major road vehicle, to allow minor road vehicle to travel from decision point to intersection and then cross major road. So, there are essentially two components of time. One is the time required to travel from decision point to the intersection and then time required to cross the major road. So, the total time required could be estimated and the required length along the major road can be estimated accordingly. So, if Tg is the total time required, then Tg is expressed as Ta plus W plus La divided by 0.167 V minor, where V minor is the design speed or mid block speed for minor approach or the minor road. Now, Ta is the time, this component is the time required to travel from decision point to the intersection. Just now we have discussed about this time component. Now, plus the time required to cross the intersection. This is estimated as the width plus length of the vehicle. So, W is the width of intersection and La is the length of the design vehicle. Do remember that this is again a function of the design vehicle. So, it will vary depending on the design vehicle. Now, this is the total distance that is required to be crossed divided by the speed. Now, normally V is expressed in kilometer per hour. So, the conversion factor is normally 0.278. In this case, carefully note that this factor is 0.167. Now, why it is 0.167? Because it is assumed that vehicles will reduce speed up to 60% of the mid block speed. So, 60% of that speed. Therefore, the correction factors become 0.6 multiplied by 0.278. So, that is approximately equal to 0.167. So, it becomes the effective speed after reduction of speed to 60%. So, we can calculate what will be the time required Tg. Now, once this time is known, the length of the leg along the major road, the length of the leg along the major road, that can be estimated like this: 0.278 V major, remember that it is V major multiplied by Tg, the time gap. Now, here 0.27 is the normal conversion factor, because we are using V in terms of kilometer per hour. Now, the Tg value, in the previous page we have seen how this Tg can be calculated. So, once this total time gap is known, what is the required length based on the design speed of the major road, that can be calculated. Now, remember that the value of Tg should equal or exceed, the appropriate travel time for crossing the major road from a stop controlled approach. A similar approach was also used for stop controlled intersection. Whatever was the value for t or the time in that case, in this case the value should equal or exceed that time value. Now, let us see, refresh our memory, what was the actual time gap. For stop control, the time gap was 6.5 seconds to 10.5 seconds depending on design vehicle type, 6.5 seconds for car and higher values for commercial vehicle type. So, when we are calculating Tg using the earlier formula, that is this page Tg, then the calculated value, if it becomes lesser than this time gap, that is, say for car it is 6.5, then we must take this value whatever is recommended for stop control approach. Say for example, for car, if we find Tg is less than 6.5, then while calculating the length of leg along major road, we shall assume Tg as 6.5. Similarly, a different value should be assumed for other design vehicle. Now, if the major road is a divided highway with median which is wide enough to store the design vehicle, in that case the approach should be slightly different, because till now we discussed about undivided roads. If it is a divide road and median width is sufficient to store the design vehicle, then only crossing of the near lanes needs to be considered, because rear lane crossing need not be taken into consideration along with near lanes, as the design vehicle can stop using the wide median, which can accommodate the design vehicle. And then in that case, so we shall consider crossing of near lanes only, and then the vehicle can be stopped in between using the median. Therefore, a departure side triangle for accelerating from a stopped position in the median should be provided, because the vehicle may stop in the median. So, from stopped position, obviously it will be a case for departure side triangle. So, a departure side triangle for accelerating from a stopped position in the median should be provided. Now, let us consider case 2, that is left and right turns from minor road. So, in this case also we have to see the length of leg along the minor road and also the length of leg along the major road. Now, length of leg along the minor road, AASHTO recommends the length as 25 meter, a fixed value. Now, this 25 meter is based on the assumption that drivers making left and right turns without stopping, remember this part, without stopping will slow to a turning speed of 16 km/h. That means, vehicles which are taking turn either to the left or to the right, they will further reduce speed, which will be acceptable or comfortable for making the turns, and that speed is 16 km/h. So, considering this aspect, the length of leg along the minor road is recommended as 25 meter. Now, let us see how the length of the road along the minor road can be calculated. So, length of the leg along the major road. This approach is again similar to stop control intersection, but with some modification. Now, let us see first what was the recommendation for left turns at stop control intersection. The time gap was recommended as 7.5 seconds to 11.5 seconds depending on design vehicle. Obviously, these values are for 2-lane highway with no median and minor road grade 3% or less. Now, this value was 7.5%, 7.5 second for car and higher value for heavier design vehicle. So, that was the time gap recommended for left turns at stop control intersection. Here minor modification is done on this design time. The time gap here is increased by 0.5 seconds. Time gap here is increased by 0.5 seconds. So, earlier value for stop control intersection, it was 7.5 to 11.5. In this case, it is 8 seconds to 12 seconds, again depending on design vehicles, and this range is for 2-lane highway with no median and minor road grade 3% or less. So, here half a second more value is assumed as compared to what was taken for stop control intersection. There it was 7.5 seconds to 11.5 seconds. In this case, it is 8 seconds to 12 seconds. Now, let us try to understand the basis for this increment in time by half second. Why it is increased? It is found that minor road vehicle needs 3.5 second additional time to travel from decision point to the intersection for yield control approach. This was not there, this component was not necessary for stop control intersection. So, this is the additional component which is required for yield control approach. Now, at the same time, the acceleration time after entering the major road is 3 seconds less for a yield sign rather than or as compared to that for a stop sign. So, here it is 3.5 seconds less. Now, why it is less? Because for yield control intersections, it is assumed that drivers will reduce speed substantially, but they will not stop. At least for the design consideration, vehicles are assumed to travel at a slow speed, but vehicles are not stopped, whereas for stop control approach, vehicles are required to stop. Therefore, the acceleration time will definitely be higher for stop controlled approach, because vehicle will start from 0 speed. In this case, it is not 0 speed. So, there is a saving of 3 seconds. So, there was additional time requirements of 3.5 seconds and there is a saving of 3.5 seconds. So, as a net result, it is half a second more time that is required for yield controlled intersection. That is why the time gap is taken as 8 seconds to 12 seconds depending on the design vehicle. Now, for left turns on two-way highway with more than 2 lanes, 0.5 second should be added if the design vehicle is passenger car, and for each additional lane from the left in excess of 1, that is to be crossed by the turning vehicle. So, I have mentioned it that the values which were mentioned earlier, 8 seconds to 12 seconds, they are for 2-lane highway. So, if more wide highway is considered for left turns, then corrections should be applied depending on design vehicle and the number of lanes that is to be crossed in excess of 1 by the turning vehicle. So, that value is 0.5 second for passenger cars, a different value is suggested for other design vehicles. For right turns, of course, no such adjustment is necessary. Now, departure side triangles like those provided for stop controlled approaches should also be provided for yield control approaches. This is because of the fact that if there is a conflicting vehicle, then vehicles approaching from a minor road also may have to stop. So, if they stop, then the departure side triangle will be appropriate consideration. So, departure side triangle like those provided for stop controlled approaches should also be considered. But normally no specific check for departure side triangles at yield controlled intersections is needed, as approach side triangles for turning maneuvers at yield control approaches are larger. So, if we design side distance considering yield control approach and considering the left turn and right turn without stopping, then the required side distance whatever will be obtained will normally be larger than the stop control requirements. So, no specific check is normally required. If side distance sufficient for yield control is not available, then one may recommend or one may explore the possibility of using stop sign instead of yield sign, because then it will be a stop controlled intersection and the required side distance will be less as compared to yield controlled intersection. Further, at locations where recommended side distance cannot be provided, one should explore the possibility of installing regulatory speed sign or other traffic control devices on the major road. Remember that we are talking about on the major road to reduce approach speed of vehicles from major road, because you have seen for a given time gap the actual length required will depend on the design speed. So, if a regulatory measure is taken to reduce the speed either by regulatory speed sign or by with the help of other traffic control devices, then the required side distance along the major road can be reduced or can be minimized. Now, let us see the case D, that is traffic control or traffic signal control, intersections which are controlled by traffic signal. In this case, the consideration for side distance is based on the fact that the first vehicle stopped on one approach should be visible to the drivers of the first vehicle of all other approaches. The first vehicle stopped on one approach should be visible to the drivers of first vehicle stopped on all other approaches. In addition, for left turning vehicles we are saying considering US convention of driving. In Indian condition, this is actually the right turn. So, left turning vehicles should have sufficient side distance to select gaps in oncoming traffic and complete left turn. This is the additional consideration that may be taken. No other approach or departure side triangles are needed for signalized intersection. In fact, signalization may be an appropriate crash countermeasure for higher volume intersections with restricted side distance and those which have experienced intersection related problems and crashes. Now, there is another special consideration for signal intersection or the signal control. They are as follows. If the traffic signal is to be placed on two-way flashing operation, what we mean by two-way flashing operation is like this: flashing yellow on the major road approaches and flashing red on the minor road approaches under off-peak or night time conditions. If this is the operating condition, then it is necessary to provide appropriate departure side triangles for case B for the minor road approaches, because vehicle may stop. So, in that case, whatever considerations we have discussed for case B, that is for stop controlled approach, intersection with stop control on minor road, that is to be applied. case E is all way stop control, all way stop control. In this case also, like signal control, the fast vehicle stopped on one approach should be visible to the drivers of the fast vehicle stopped on each other approaches. There are no other side distance criteria applicable for intersections with all way stop control. In fact, all way stop control may be the best option at a limited number of intersections where side distance from other control types or side distance required for other control types cannot be attained. So, in those cases, in a limited number of intersection, one can go for all way stop control for simplicity and for enhanced safety in terms of the side distance availability. Now, case F, that is left turns from major road. Now, here we are talking about locations where vehicles on major roads are permitted to take left turns across opposing traffic. Remember that again we are using US convention of driving. So, vehicles are permitted to take left turns across opposing traffic. So, if say this is the vehicle which is traveling along the major road, they have to take left turn like this. Okay. So, against this opposing movement, opposing traffic. So, therefore, left turn drivers need sufficient side distance to decide when it is safe to take left turns across the lane used by opposing vehicle. And side distance design should be based on a left turn by a stopped vehicle. Now, carefully observe this word design. Design should be based on a left turn by a stopped vehicle. Now, why it is stopped vehicle? The reason is, if vehicle is in motion, then it will normally require a lesser side distance as compared to a vehicle which is stopped. So, therefore, for design consideration, it is considered that a vehicle is taking left turn and that vehicle is a stopped vehicle. So, if the available side distance is sufficient to satisfy this requirement, then automatically it will satisfy the requirement of those drivers which will take left turn without stopping. So, that is why it is based on a left turn by a stopped vehicle. The side distance along the major road to accommodate left turns is the distance traversed at the design speed of the major road in the travel time for design vehicle. Whatever travel time is required for the design vehicle to complete this left turn, and that much time whatever distance is covered by a vehicle which is traveling along the major road in design speed, that will give us the length of the or the required side distance along the major road. So, this time gap as per AASHTO, it is 5.5 seconds to 7.5 seconds. That is the time gap which is recommended by AASHTO based on the field observations. And this value 5.5 seconds to 7.5 seconds, it varies depending on the type of design vehicle. So, for passenger cars it is 5.5 seconds, for heavier vehicles, commercial vehicles, if they are taken as design vehicles, then the required time is higher and it may go up to 7.5 seconds. So, whatever is the distance covered along the major road, if major road speed is V major, then 0.278 into V major into this appropriate time 5.5 to 7.5 depending on the design vehicle, that will give us the required length. With this we have, okay, let us see, there are a few more aspects. Now, for left turning vehicles, whatever values we have discussed, we have mentioned in the last slide, 5.5 second to 7.5 second, they are actually for 2-lane road. So, for turning vehicles or left turning vehicles that cross more than one opposing lane, 0.5 seconds should be added for passenger car and a separate value is recommended for other vehicle types, design vehicle, for each additional lane to be crossed. Obviously, if it is a wider road, more number of lanes are to be crossed. So, therefore, more time is required. So, AASHTO recommends that 0.5 seconds for passenger car should be taken for each additional lane to be crossed. Now, if stopping side distance has been provided continuously, normally throughout the length of the highway, stopping side distance is provided. So, therefore, if stopping side distance is provided at all points along the highway, and if side distance for stop control or yield control has also been provided for each minor road approach, then available side distance will generally be adequate for left turns from the major road. So, separate consideration or separate checks may not be necessary. So, if throughout the length of the road stopping side distance is available and at all minor intersections with stop control or yield control appropriate side distance is available, intersection side distance is available, then normally it is not necessary to check for the left turning traffic intersection, a requirement of side distance for left turning traffic, because normally the side distance should be adequate for this kind of maneuvers. Now, with this we have completed our discussion about all 6 different types of control considered in AASHTO and the basis for intersection side distance for each control type. Let us look at the Indian conditions, particularly the recommendations given by Indian Roads Congress. IRC considers 2 different types of at-grade intersections. One is uncontrolled intersections as indicated here. The other set is priority intersections. Now, uncontrolled intersections are those intersections where priority of both roads are equal. no special or no higher priority or lower priority for any road. Both intersecting roads normally have equal priority. For priority intersections, priority of one road is higher than the priority of the other road. So, it is a case where a major road and a minor road, they are intersecting. Let us see the IRC recommendations first for uncontrolled intersections. The area of clear visibility should be determined with respect to stopping side distance for each highway corresponding to design speed. That means, IRC straightway recommends that each approach should be equal to the required stopping side distance depending on the design speed for that approach. So, if there are two roads and the design speeds are different, then one can easily calculate what is the required stopping side distance corresponding to the design speed of road 1 and also corresponding to the design speed of road 2, then that will give us the dimensions for the side triangle. So, straightway it says that it should be on the basis of stopping side distance, and IRC the basis used in IRC for stopping side distance, that we have already discussed earlier. Now, if adequate side distance is not available, then vehicles must be warned to travel at speeds corresponding to the available side distance. That means, if due to cost consideration, suppose the required area is not available, clear area is not available, and there is an obstruction which will be, and where it is very expensive or costly to remove that obstruction. In that case, we may still compromise with a lesser dimension of side triangle, but in that case approach speed is to be modified. So, it says that vehicles must be warned to travel at speed corresponding to available side distance. One can see what is the available side distance, and that side distance what speed it can accommodate. So, accordingly there should be speed restriction. Now, it could be done like on both roads one can restrict the speed, or it could be done other way, like for one road one can assume the design speed, and then on the other road whatever is the available side distance, accordingly the speed restrictions can be imposed on the other road. But the basis is SSD, or the stopping side distance. For priority intersections, we have to find out the minimum distance along the major road and the distance along the minor road to get the required side triangle. Now, minimum distance along the minor road as per IRC, it is recommended as 15 meter for design purpose. For all priority intersection, this is 15 meter. Along the major road, the basis is the time required by the driver on the minor road to perceive traffic conditions, part 1, part 2 evaluate the gaps, part 3 take decision about crossing, and part 4 finally accelerate the vehicle to complete the maneuver. So, for all these components, whatever is the total time required for vehicles along the minor road. So, accordingly that time is taken as 8 seconds, and distance along the major road equal to 8 seconds travel at design speed is recommended. That means, the distance along the major road is 0.278 into V major that means design speed for the major road multiplied by t, that is 8 seconds. So, that will give us the length. Now, let us try to answer some of the questions. Explain the basis for obtaining intersection side distance considering crossing maneuver from the minor road with yield controlled. This is what is the basis used in AASTO for this particular situation. Number 2, compare length of side triangle along the major road considering left turn maneuver for both yield controlled intersection and stop control on minor road. Compare the length as obtained for yield controlled intersection and as obtained from stop control on minor road. Third, discuss IRC recommendations for intersection side distance for uncontrolled intersections and priority intersections. So, try to answer to these questions. Now, I shall quickly try to answer the questions which were raised during lesson 3.5. Explain the concept of approach side triangles and departure side triangles. Let us see what is the side triangle. Side triangle is the specified areas along intersection approach legs and across their included corner which should be clear of obstructions that might block a driver's view of potentially conflicting vehicle. So, we have a major road and a minor road. What is the triangular area that should be free from obstruction? That is side triangle. Now, approach side triangle is the triangular area free of obstruction that might block an approaching driver's view. An approaching driver's view, that means vehicle is in motion of potentially conflicting vehicles. Now, for departure side triangle, it is the same side triangle, same concept, but here it is for to provide side distance sufficient for a stopped driver on a minor road approach to depart from the intersection and enter or cross the major road. So, one case approach side triangle is for moving vehicles, departure side triangle is for stopped vehicles. Next question was mention different types of intersection control considered by AASTO for the estimation of intersection side distance. Different intersection controls are no control, case B stop control on minor road, case C yield control on minor road, D traffic signal control, case E always stop control, and case F left turns from minor roads. So, AASTO considered all these 6 cases. The last question was for an intersection with stop control on minor road, what should be the dimension of side triangles considering left turn from minor road? Design vehicle is car, design speed for the major road is 100 km per hour, major road is a 4-lane divided road and minor road approach is located on a 4% upgrade. Now, along the minor road, the decision point is 4.4 meter from the edge of the major road. So, this is the distance which is 4.4 meter. Now, what should be the length of additional length, that is this length, and in this case considering the traffic from right, this length, that can be obtained easily considering the width of the road. So, if it is a 4-lane road, accordingly one can calculate. Along the major road, normally it is 7.5 seconds to 11.5 seconds, that is for car, but for multi-lane highway 0.5 seconds for each additional lane is to be added, that is to be crossed by the turning vehicle. Since it is a 4-lane road, So, one additional lane is to be crossed, instead of one lane it is to be 2 lanes. So, 0.5 second is added, making it 8 seconds. That is the effect of width. Now, what is the effect of grade? That it says, AASHTO says that in excess of 3%, 0.2 seconds may be added for each percentage grade. So, it is a 4% grade, means 4 into 0.2, that is 0.8 seconds. So, total is 8.8 seconds. The approach speed is known. So, the length is 0.278 into 100 kilometer per hour into 8.8. So, that gives us 244.64 meter. That way one can calculate the length. Thank you.